National Electrical Code Section 300.36 does not apply, as it addresses conductors over 600 volts nominal. Similarly, Section 336.24 concerns Type TC tray cable, which is not the subject of this discussion. The relevant information regarding wire bend radius for single conductor wire rated for 600 volts or less can be found in National Electrical Code Section 314.16b6. This section specifically deals with the minimum bending space at terminals and minimum wire bending space at terminals, and it is crucial for ensuring safe and compliant electrical installations. The wire bending space provided shall be sufficient for the installation of conductors in a neat and workmanlike manner. The code mandates that conductors shall not be bent or damaged during installation. The wire bending space at terminals shall comply with Table 312.6 for installations without entries at the opposite wall to the terminal, and Table 312.6b for installations with entries at the opposite wall to the terminal. These tables provide specific dimensions based on the conductor size and the number of conductors in the enclosure. To properly apply Section 314.16b6 in Tables 312.6 and 312.6b, it's essential to understand several key factors. Firstly, the conductor size directly affects the required bending space. Larger conductors necessitate more space to accommodate their larger radii. Secondly, the voltage rating of the conductors, though in this case specified as 600 volts or less, is a fundamental parameter. Thirdly, the type of enclosure or equipment in which the conductors are being installed influences the applicable requirements. Fourthly, whether the conductors enter the enclosure from the opposite wall of the terminal affects the necessary bending space as indicated by the choice between Tables 312.6 and 312.6b. Fifthly, the number of conductors within the enclosure also plays a role, as it determines the overall congestion and the space needed to manage the bends. Now, let's elaborate on the significance of these tables and how to use them effectively. Table 312.6 provides the minimum wire bending space at terminals for installations where conductors do not enter the enclosure opposite the terminal. This situation typically arises when conductors enter from the top, bottom, or sides of the enclosure. The table is organized by conductor size, ranging from number 14 American wire gauge to 2000 kc mil, and specifies the minimum bending space in inches based on the applicable voltage. For example, if you are installing number 6 American wire gauge conductors rated for 600 volts in an enclosure where the conductors do not enter opposite the terminals, Table 312.6 will specify the minimum required bending space. Conversely, Table 312.6b applies when conductors enter the enclosure directly opposite the terminal. This arrangement often requires more bending space due to the more acute angles involved in routing the conductors. Like Table 312.6a, Table 312.6b is organized by conductor size and provides minimum bending space dimensions in inches. Again, the conductor size and voltage rating determine the specific value to be used from the table. The NEC defines wire bending space as the distance from the wire termination point to the wall of the enclosure or to any barrier inside the enclosure opposite the termination point. This space is critical for ensuring that the conductors can be bent without exceeding their minimum bending radius, which could damage the insulation and compromise the integrity of the electrical system. In addition to the requirements outlined in Section 314.16b6 and Tables 312.6 and 312.6b, there are general rules for conductor installation that must be followed. Conductors should be installed in a neat and workmanlike manner, meaning they should be properly supported, bundled, and routed to avoid strain and stress. Conductors should not be bent or damaged during installation, as this can compromise their insulation and current carrying capacity. Furthermore, conductors should be identified by color coding or other means to facilitate troubleshooting and maintenance. Proper identification helps prevent accidental disconnection or misconnection, which can lead to electrical hazards. When installing conductors in enclosures or equipment, it is important to use the correct fittings and connectors. Fittings and connectors should be listed for the intended application and should be properly installed to ensure a secure and reliable connection. Over-tightening connectors can damage the conductors, while under-tightening can result in loose connections and potential arcing. The NEC provides specific requirements for the types of fittings and connectors that can be used for different conductor types and applications. These requirements are intended to ensure that the connections are mechanically sound and electrically safe. In addition to following the NEC requirements, it is essential to adhere to industry best practices for wire bending and termination. Use appropriate tools for bending conductors to ensure that the bends are smooth and consistent. Avoid kinking or sharp bends, as these can damage the insulation and reduce the conductor's current carrying capacity. When terminating conductors, strip the insulation carefully to avoid nicking or cutting the conductor strands. Use a torque wrench to tighten connectors to the manufacturer's specified torque to ensure a secure and reliable connection. Regularly inspect electrical installations to identify and correct any problems such as loose connections, damaged insulation, or corroded conductors. Regular maintenance can help prevent electrical hazards and extend the lifespan of the electrical system. When working on electrical systems, always to energize the circuit before starting any work. Use appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect yourself from electrical shock and other hazards. If you are not qualified to perform electrical work, hire a licensed electrician to ensure that the work is done safely and correctly. Electrical safety is paramount, and it is essential to take all necessary precautions to prevent accidents and injuries. In summary, when addressing wire bend radius for single conductor wire rated 600 volts or less, consulting section 314.16b6 in conjunction with tables 312.6 and 312.6b is necessary. These resources provide the specific requirements and guidance needed to ensure safe and compliant electrical installations. Adhering to these standards not only ensures the safety of individuals and property, but also contributes to the overall reliability and longevity of electrical systems.